So here's a wild thought. Can an AI that only understands text learn to read something totally new, like the 3D shape of a molecule, instantly, without any training at all? I know, it sounds pretty much impossible, but some brand new research is saying, hold on a second. Let's get into it. Okay, to really get this, think about it like this. How would you explain the color red to someone who's only ever seen in black and white? I mean, you can use words like passion or fire, but they'll never really get the experience, right? Well, that's the exact problem we have with large language models, LLMs. They are wizards with words, but the world isn't just made of words. So the big question is, how do we bridge that gap? All right, first things first, let's really nail down what we're talking about here, the LLM's text-only universe. I mean, we all know LLMs are incredible masters of language. Seriously, they can write you a poem, debug your code, explain quantum physics, you name it. Their superpower is that fluency with words. But, and this is a big but, what happens when the information you need isn't in a text file? Well, that's where we hit a pretty solid brick wall. So you can see here on one side you've got everything the LLM is comfortable with. Plain text, computer code, even these clever text-based ways of writing down molecules called smile strings. But on the other side, well, that's a whole universe of data it's completely blind to. The actual 3D shape of a molecule, images, audio clips, sensor data, you name it. It's exactly like being a genius in one language, but completely deaf and blind to every other language on Earth. Okay, so if that's the problem, how have we tried to solve it in the past? Well, the traditional way to teach an AI a new language like this is, let's just say it's slow and really, really expensive. Yeah, the old solution is basically like sending the LLM off to a super expensive, specialized language school. Think of it like an Ivy League university for AI. And just like that, it means a long, drawn-out, and costly training process. In this language school is no joke. We're talking about needing these massive, specialized datasets that someone has to painstakingly label by hand. It requires insane amounts of computational power, running for days or even weeks. But you know what the biggest headache is? It's totally inflexible. If you want to teach it another new data type tomorrow, you guessed it, you have to start the entire expensive process all over again from scratch. But what if there was a shortcut, a genius workaround, a way to just bypass the school entirely? Well, that is exactly where this fascinating new research comes into play. This is really the core idea, the question that changes everything. What if, instead of going through all the trouble of sending the LLM to school, we could just give it an instant universal translator? Like a Babelfish from Hitchhiker's Guide, but for AI. What then? And this brilliant idea has a name, in-context representation learning, or ICRL. Now, the magic words here are training free. That's the whole point. Instead of retraining the whole model from the ground up, you basically extract the essential meaning from the non-text data and inject it directly into the prompt you're giving the LLM. It's literally like handing it a cheat sheet it can use in real time. So, how in the world does this universal translator actually work? Well, it all boils down to two really clever strategies the researchers came up with. Okay, so there are two main ways they figured out how to inject this new knowledge. The first approach is to kind of translate the data into a special compact piece of text. The second way is, well, a lot more direct. It injects the knowledge straight into the AI's brain, so to speak, at a much deeper level. All right, let's break these down. The text-level way uses a cool technique called PCA to basically shrink down a ton of complex data into a simple, neat text string. The best way to think about it is like inventing a brand new word that perfectly captures the essence of a molecule. Then there's the embedding-level approach, which is even more wild. It uses something called optimal transport to directly map the structure of the data onto the LLM's internal map of the world. It's like injecting a fully formed thought that the AI can understand immediately without any translation. Okay, so that's the theory. It's a super clever idea for sure. But the million-dollar question is, did it actually work? Let's check out what the researchers found. And the answer is a huge, resounding yes. It absolutely worked. I mean, think about this. Without a single moment of retraining, a regular, off-the-shelf, text-only LLM could suddenly start to reason about complex molecular data. This isn't just a small step, it's a massive breakthrough. And hey, don't just take my word for it. The numbers speak for themselves. On this chart, we're looking at how well the AI predicted molecular properties. Lower scores are better here. The standard text-only method gets a score of 1.16. But look at the ICRL methods. They both scored lower, with the best one hitting 1.09. That's clear proof that this technique isn't just a gimmick, it's genuinely effective. But wait, it actually gets even better. See, ICRL doesn't have to replace the old ways. When you combine it with the standard text-based methods, it acts like a booster shot for the AI's performance, making its existing skills even sharper. Now this, to me, might be the most fascinating part of the whole study. The researchers discovered something really unexpected. These injected little bits of data seem to act like pause tokens. It's like by giving the LLM this weird, new piece of information, you're forcing it to slow down for a second, to think a little deeper about the problem. And that extra processing time actually leads to better, more accurate answers. How cool is that? So let's step back for a second. What does all of this really mean? What are the bigger implications here? Because this is way more than just a clever coding trick. This could be a whole new path forward for creating truly adaptable AI. Really, the bottom line is this simple. ICRL makes building powerful, versatile AI dramatically cheaper, faster, and way more accessible to everyone. It's tearing down technical and financial barriers that have been holding back progress for years. And when I say dramatically, I mean it. Just look at this comparison. The most powerful traditional methods can take around 2 weeks to train. This new ICRL method, it takes about 2 seconds. And in those 2 seconds, it gets results that are right up there with the much slower, more expensive methods. That's not just an improvement. That is a complete game changer. And this is really why this matters so much. Suddenly, a small university research lab, or a tiny startup, or even just a hobbyist can give a powerful AI the ability to understand their own unique, specialized data on the fly. It truly democratizes access to this level of AI, opening the door for new discoveries in all sorts of fields that used to be locked out by the insane costs. So this really leaves us with one massive, exciting question to think about. If an AI can learn to understand any new kind of data, any new language, in a matter of seconds instead of weeks, what new problems could we finally solve? What incredible breakthroughs that once seemed impossible are now suddenly within our reach?